In this lesson, we're going to look at how to solve some linear inequalities that are maybe just a little more complicated than the ones we've looked at before. So let's kind of review what we've learned about solving. We know whenever we solve equations or inequalities, if there's anything to distribute, that should be done first. We should combine like terms on the left side and on the right side separately. Then we isolate the x term, or the variable term doesn't have to be x, and that's usually an adding or subtracting step. And then we isolate the variable, and that's usually a division step, although it can be multiplication. And really that's it. Except when we're solving inequalities, we have to remember that if you multiply or divide by a negative, you have to flip the inequality symbol over. So now let's solve a few together. Let's do 7x plus 15 is greater than or equal to 13x plus 51. So since we have both kinds of terms on both sides of the variable here, the first thing I would do is eliminate one of these variable terms. And I'm going to eliminate the 7x because it's the smaller variable term. And the reason I want to do that is so that my variable term will end up positive. Now it will end up on the right side of the inequality, and we'll see later that we will want to reverse it so it's on the left side, but at least it will be positive. And that leaves us with 15 is greater than or equal to 6x plus 51. Now let's eliminate the plus 51 from both sides. And that will leave us with negative 36 is greater than or equal to 6x. Now we're going to divide both sides by 6, and it's a positive 6. So that will leave us with negative 6 is greater than or equal to x. So with the number on the left and the variable on the right, this is not in the form that I want to graph in. Remember we said you can graph in the same direction that your symbol is pointing as long as the variable is on the left. So instead of saying negative 6 is greater than x, I'm going to say that x is smaller than negative 6. See, it says the same thing, but it says it with the variable first instead of with the number first. So this is the same meaning as the inequality that we got as our answer. Now this one's easier to graph. So I will put negative 6 on the number line, and we will shade to the left, and we will use a bracket because of the or equal to bar, and then our interval notation will be from negative infinity to negative 6, bracket, and our set builder notation is all the x's such that x is less than or equal to negative 6. It's just the same inequality that we found here as our answer. Now let's solve 3 times x plus 5 minus 8 is greater than or equal to 6 times x plus 2 minus 5 times x plus 1. So we will distribute the 3, and we will distribute the 6 and the minus 5. Okay, now on the left side I have terms that are alike. The plus 15 and the minus 8 can be combined to give us plus 7. On the right side, 6x minus 5x combines and gives us 1x. 12 minus 5 combines and gives us 7. Now I have both kinds of terms on both sides of the equal mark, so I will eliminate the smaller x term, and that will leave us with 2x plus 7 is greater than or equal to 7. Now I'm going to subtract 7 from both sides, and that will leave us with 2x is greater than or equal to 0. So I need to divide both sides by 2, and that will leave us with x is greater than or equal to 0, because 0 divided by 2 simplifies to 0. I can graph this by shading to the right. We'll use a bracket because of the or equal to line, and then our interval is from 0 to infinity. Set builder notation is the set of all x's such that x is greater than or equal to 0. Now I want to show you how to check an inequality. To check an inequality, we need to do two things. We first need to make sure that the number in our inequality is the correct number. And then we need to make sure that the shading is going in the right direction. So in order to find out if the number is right, we plug it in and check it like we've been checking our equations. And in order to make sure that the shading is right, we can plug in any number that's in the shaded part of the line and make sure that the inequality is true. So when we check the number, it checks like an equation. When we check the shading, we treat it like an inequality again. Let's see how it looks. We're going to check the solution for negative 2x minus 4 is greater than x plus 5. So this is an inequality that we had in a previous lesson, and when we solved it, we came up with x has to be less than negative 3, and this was the graph that we got. So in order to check this, first I'm going to see if negative 3 is the right number, and do that by plugging in negative 3, making sure that they add up to the same thing. So here's negative 2 times x minus 4 equals x plus 5. So on the left, negative 2 times negative 3 is 6, and 6 minus 4 is going to be 2, and on the right, negative 3 plus 5 is 2. And so since both sides are the same, we know that negative 3 is the correct number. Now I need to make sure that the shading is going the right way. So I will pick anything that's in the direction of the shading and just make sure that it makes the inequality true. So I'm going to choose negative 10 only because it's in the shaded area. And you could choose any number that's in the shaded part. Negative 4, negative 50 would work. Any of these numbers that are to the left of negative 3. I just couldn't use, say, negative 2 or 1 or 5 because all of those numbers are to the right of negative 3. So when I plug in negative 10, what I get is 20 minus 4 on the left and negative 5 on the right. And since 20 minus 4 is 16, I know that this inequality is true. 16 is greater than negative 5. So I feel like, we've got the shading going right. Well, if we got the number right and the shading right, then the whole thing is okay.